Welcome to Night Chemistry. Take a deep breath, close your eyes, and allow yourself to gently drift into the calming world of science. Tonight, we journey back in time to a quiet Parisian evening, more than a century ago, when gentle candlelight illuminated the modest laboratory of Marie Curie, a woman whose discoveries would forever change the course of history. Relax, listen, and let yourself gently drift towards sleep as our chemistry bedtime story begins. The streets of Paris lay quiet and calm beneath a soft blanket of darkness. Gas lamps flickered gently, casting golden reflections on the wet cobblestones, their warm glow creating delicate patterns on the narrow avenues. A gentle mist hung low over the city, wrapping it in an almost dreamlike veil of serenity. Along the banks of the Seine, the rhythmic lapping of water against stone embankments created a comforting, soothing sound, like a gentle lullaby played by nature itself. It was late in the evening, almost midnight. Most Parisians had long since drifted off into restful sleep, their windows dark, their houses quiet. Yet, tucked away in a small building on Rue Lamond, a faint light still glowed softly, illuminating a single window from within. Behind that window was a modest laboratory, a room so simple and unassuming that passers-by rarely gave it a second glance. But within its walls, something extraordinary was quietly unfolding. Inside the laboratory, wooden shelves lined the walls, filled with glass jars, carefully labeled vials, and mysterious powders neatly arranged in rows. In the gentle candlelight, these objects cast long, shifting shadows, creating an almost magical dance upon the worn wooden floor. The air was filled with subtle aromas, scents of chemicals and minerals, mixed with a hint of old paper and wax candles. At the center of this quiet, peaceful room stood a woman, carefully leaning over a delicate glass flask, her eyes intently fixed upon the substance it contained. Her hair was neatly gathered, though a few strands had slipped free, softly framing her concentrated face. Her expression was calm yet deeply thoughtful, reflecting a lifetime of curiosity and gentle determination. This woman was Marie Curie. Marie moved gracefully but deliberately, her hands steady and precise as she measured small quantities of minerals, carefully mixing them together, observing changes with patient, focused attention. Her movements were almost rhythmic, each step familiar from years of dedicated practice. Occasionally, she paused to jot down notes in a leather-bound journal, her handwriting meticulous and neat, each letter formed with the same calm precision that characterized all aspects of her work. Marie's experiments had begun long before this quiet night. They were born from a simple yet profound curiosity, a desire to understand the invisible forces that seemed to flow silently, yet powerfully, through the natural world. For Marie, these unseen phenomena represented a beautiful mystery, a puzzle waiting patiently to be solved. Each experiment, each observation brought her one small step closer to unraveling secrets that others had scarcely even imagined existed. In these peaceful nighttime hours, when the bustling world outside lay sleeping, Marie found herself most productive, her mind clearest and most receptive. The quiet solitude allowed her thoughts to flow uninterrupted, her intuition sharpened, guiding her gently toward new insights and discoveries. Her nightly routine became a comforting ritual, lighting candles, preparing her equipment, reviewing notes from previous nights, and beginning her careful, deliberate experiments anew. Tonight, however, was particularly special. Marie had noticed something intriguing in her recent experiments, a faint but undeniable glow emanating from certain mineral samples she had been studying. This gentle luminosity fascinated her deeply. It was unlike anything she had ever encountered before, a mysterious radiance that seemed to defy explanation. Carefully, she held up one of these small samples to the candlelight, turning it slowly in her hand. In the dimness of the room, the glow became clearer, a soft, delicate blue-green luminescence gently illuminating her fingertips. It was as if the mineral itself held within it a hidden source of quiet light, patiently waiting to be discovered. Marie's mind raced calmly through possibilities. her curiosity blossoming into careful excitement. Could this soft glow indicate something fundamentally new? Could it be connected to those mysterious rays recently discovered by Henri Becquerel? She felt an inner certainty, a gentle intuition whispering softly to her that she was on the verge of something extraordinary. But Marie was patient. She knew discoveries required careful observation, repeated experimentation, and above all time. She gently placed the glowing mineral sample back onto the laboratory table, arranging it thoughtfully beside her other specimens. Then, turning to her journal, she began meticulously documenting her observations, carefully noting the mineral's appearance, its behavior under different conditions, and the precise details of the glow she had observed. Outside, the night continued its quiet journey toward dawn. The streets remained still, the mist gently swirling around the gas lamps, their light now softened by the approaching hours of early morning. Within the peaceful sanctuary of Marie's laboratory, the slow, rhythmic scratching of pen against paper filled the air, blending harmoniously with the distant murmuring of the Seine. Marie paused briefly, allowing herself a moment of gentle reflection. She gazed out of the small laboratory window, her eyes thoughtfully tracing the outlines of Paris rooftops silhouetted against the night sky. In moments like these, she felt profoundly connected, not only to her work but to the universe itself. The gentle mysteries she explored in her laboratory were, she realized, simply part of a greater, beautiful mystery, the wonder of existence quietly unfolding all around her. With a soft, contented sigh, Marie returned to her journal, carefully completing her notes. Her eyes, though tired from long hours of concentration, sparkled with gentle joy and anticipation. Tonight marked the beginning of a remarkable new journey, a journey toward understanding a mysterious force she would soon call radioactivity. As the night gently passed into early morning, Marie concluded her tasks, neatly organizing her notes and carefully extinguishing each candle, one by one, until only the soft glow of her mysterious mineral sample remained, casting its faint, ethereal light upon the quiet darkness. Marie stood silently, gazing at the gentle glow for a moment longer, feeling a quiet sense of wonder and gratitude. Tomorrow, she knew, would bring more questions, more experiments, and perhaps even greater discoveries. But tonight, as she quietly closed the laboratory door behind her, stepping out into the peaceful Parisian streets, she allowed herself a gentle, satisfied smile. The journey had begun, illuminated by the soft, mysterious glow that would guide her path through many more quiet nights like this one. Childhood and youth. Far from the lantern-lit streets of Paris, our story rewinds to another city wrapped in night, Warsaw, Poland, in the late autumn of 1867. A thin veil of early morning fog wound its way between the narrow alleys of the old town, brushing gently against crimson-tiled roofs and resting, like a quiet promise, on statues that lined the deserted marketplace. Within a modest flat at 16 Frida Street, candle flame shimmered beside a wooden cradle, casting golden halos across wallpaper the color of pressed linen. Inside that cradle slept a newborn girl named Maria Salomea Sklodowska, unaware that the first breath she drew into her tiny lungs would one day ripple through the whole of science. A house of learning. Maria's parents, Bronislawa, a former headmistress, and the Ladislaw, a secondary school teacher of mathematics and physics, believed that knowledge was as vital as bread and water. Their apartment overflowed with well-thumbed textbooks, maps and mineral samples stacked in cigar boxes. Evenings were spent around a square oak table beneath an oil lamp whose gentle hiss became the background music to recitations of Polish poetry, geometry problems, and laughter that drifted out through the open balcony doors toward the scented linden trees. Maria, the youngest of 5 children, absorbed that atmosphere as naturally as sunlight. By the age of 4, she could already recite the alphabet both forward and in playful reverse. At 6, she constructed tiny laboratories from ink wells, sugar cubes, and the fragrant soap slivers her mother kept in linen drawers. She mixed rainwater with crushed violet petals, whispering that she was extracting colors from the sky. Her mother smiled, smoothing Maria's hair and telling her the world always revealed secrets to those who asked gently. Shadows and resilience. Yet this warm haven was not shielded from sorrow. Tuberculosis crept into the Sklodowski household when Maria was only 10. First it claimed her eldest sister Zofia, whose absence left the corridors hauntingly silent. Then, scarcely 2 years later, it took Bronislawa herself. Maria's memory of her mother's final evening remained forever tender. The scent of lavender sachets, the stiff rustle of a prayer book, and a whispered blessing pressed like a snow-light kiss upon her forehead. Grief could have hollowed the child, but education became her lantern in the darkness. The Ladislaw, stripped of his teaching post for harboring patriotic sentiments against Tsarist rule, converted a back room into a clandestine classroom. There, Maria solved algebraic riddles on a scratched slate while winter winds rattled panes behind thick wool drapes. She discovered comfort in the certainty of equations and in the delicate architecture of chemical formulas, each subscript a stepping stone across a river of uncertainty. The Flying University. As Maria approached adulthood, avenues to higher study for women in Russian-controlled Poland were barred like iron gates. Yet resistance found subtle forms. In the twilight hours after factory whistles fell silent, groups of young women would slip through side streets toward secret gatherings known as the Flying University. The location changed regularly. An attic one week, a bookbinder's cellar the next, to evade Tsarist police. Wrapped in shawls and determination, students crouched around smuggled reagents and whispered Latin names of plants while kerosene lanterns etched daring halos on the ceiling. Maria attended these clandestine lectures with notebook pressed to her chest. She listened to impassioned discussions on Lavoisier's conservation of mass and Mendeleev's new periodic table, her pulse quickening each time she traced adjacent elements with her fingertip. Here, in whispered lessons threatened by political storms, Maria's resolve hardened like tempered steel. She would devote her life to science, no matter the barricades. Seasons of sacrifice. Yet ambition alone could not purchase passage to university abroad. To gather funds, Maria spent nearly 3 years as a governess on rural estates dotted across the rolling plains of Mazovia. Daylight hours she tutored landowners' children in arithmetic, while orchards of apple blossoms breathed sweet perfume through open shutters. At dusk, when lantern moths danced around the veranda lamps, she pored over borrowed textbooks. Balzac's prose one night, Helmholtz's treatises the next, copying entire chapters by hand so she could relinquish the volumes before dawn. Loneliness accompanied those country nights like a distant owl call. Yet Maria transformed solitude into quiet strength. She performed small experiments with kitchen utensils, timing the rate at which cream soured, noting how copper pots developed verdigris, observing the quivering meniscus of well water as gusts rattled shutters. Each observation was recorded in neat ink lines that would later fill the trunks she hauled back to Warsaw. Pact between sisters. During those years she forged an unbreakable pact with her elder sister Bronia. Maria would labor as governess to finance Bronia's medical studies in Paris. Once established, Bronia would, in turn, help Maria join her. Their correspondence, carried across borders in worn leather satchels, became threads of hope weaving the two hearts together. Letters spoke of Parisian boulevards, the scent of roasted chestnuts, and lecture halls where women's voices rang unashamedly alongside men's. 3 winters and 1 harvest passed. Maria's savings, folded carefully into linen envelopes, finally equaled the fare to France and a modest cushion for tuition. She returned once more to Warsaw to bid farewell. That December evening, snowflakes drifted past gaslights, swirling like illuminated pollen. The Ladislaw clasped her gloved hands at the train platform, whispering, "Remember, my little Menya, the road of knowledge has no end, only new horizons." Maria stepped onto the third-class carriage carrying a small trunk, a battered valise of books, and an unquenchable flame of purpose. As the locomotive exhaled plumes of steam and steel wheels clanged into motion, Warsaw's receding rooftops blurred behind frosted windows. Ahead lay Paris. City of lights, city of possibility. She settled into her seat, notebook open upon her lap, pencil poised. Outside, the snow-draped landscape unfurled under a full moon, each glistening field resembling a blank page ready to receive the ink of discoveries yet to come. Maria closed her eyes for a moment, listening to the rhythm of the train, a steady heartbeat carrying her toward destiny. Somewhere in the darkness, a distant station bell chimed midnight. Maria breathed in slowly, tasting coal smoke mingled with winter air, and whispered a silent promise to herself. I will learn, I will uncover, I will illuminate. The wheels echoed her vow along the rails, a soft percussion fading into the vast night between present struggle and future brilliance. As dawn's first pale threads of rose and gold began to weave themselves across the eastern sky, Maria Sklodowska's train rolled quietly over the outskirts of Paris. The city still slumbered under its gray winter cloak, unaware that within its labyrinth of streets soon walked a young woman whose gentle curiosity would one day set the world aglow. Paris and meeting Marie Curie. When the iron train finally exhaled its last plume of steam beneath the great glass canopy of the Gare du Nord, Maria felt a tremor of anticipation ripple through her body. Dawn's first light filtered through iron latticework, painting the stone platforms with watercolor streaks of lavender and ash blue. Porters hurried past, boots clicking on the tiles, while distant carriage wheels sent hollow echoes drifting beneath the vaulted roof. She tightened her scarf against the chill, stepped onto the platform, and tasted the sharp, briny perfume of coal smoke mingled with yesterday's rain, a scent she would forever remember as the breath of Paris. The attic en rue Flatters. Maria, now determined to call herself Marie, rented a narrow garret room near the Sorbonne, 5 steep flights above a baker whose ovens perfumed the stairwell with warm crust and anise. Her attic, scarcely larger than a railway compartment, contained a cot, a wobbly table, and a single dormer window that opened toward a sliver of sky. In winter, the water in her wash basin froze to a fragile mirror. In summer, the room blossomed with relentless heat. Yet Marie regarded these discomforts as temporary tolls on the road to knowledge. She attended lectures wrapped in a second-hand wool coat, fingers tingling from cold, clutching sepia-lined notebooks that soon filled with neat Polish-French equations. The amphitheaters smelled of ink, chalk dust, and damp wool. Professors in waistcoats gestured at blackboards crowded with symbols, Faraday's lines of force, Carnot's cycles, Foucault's pendulum, while gas lamps hissed softly overhead. Marie copied every derivation, every diagram, her pale face aglow with the quiet fire of comprehension. Money was painfully scarce. At times she lived on nothing more than buttered bread and a single cup of café au lait sipped slowly in an unheated library alcove. Hunger manifested as brief dizziness, a silvery blur at the edge of her vision. She steadied herself by reciting chemical valences, 1 hydrogen, 2 oxygen, until the dizziness retreated. Yet fatigue could not dim her joy. Each theorem mastered, each experiment observed felt like a small constellation lighting within her mind, guiding her forward. A quiet man of magnetism. One pale November afternoon in 1894, Marie visited a colleague to borrow laboratory space for measuring the magnetic properties of tempered steel. Standing beside a cluttered workbench, adjusting a sensitive electrometer, was a tall, slender man whose dark hair curled slightly over his collar. He wore round spectacles and moved with economical grace, as though every gesture had been pre-calculated to conserve energy. His name, the colleague whispered, was Marie Curie. Pierre was already known in scientific circles for discovering Curie's law of magnetism and for inventing, with his brother Jacques, the piezoelectric quartz balance, an instrument so precise it could detect changes in weight smaller than a milligram. Yet fame sat lightly upon his shoulders. He greeted Marie with a shy nod, eyes warm but hesitant, like a boy suddenly aware he is being observed. In the weeks that followed, chance, and the small Parisian scientific community, brought them together often. Pierre's laboratory occupied 2 cramped rooms off the courtyard of the School of Physics and Chemistry on Rue Cuvier. Shelves bowed under jars of crystalline salts. Wires snaked across tables to galvanometers whose needles quivered like nervous birds. The place smelled of sealing wax, ozone, and eternal curiosity. Marie, invited to use Pierre's delicate balances, approached each measurement with almost ceremonial mindfulness. She admired the way Pierre handled his instruments, palms steady, breathing slow, as though coaxing secrets from silent metal. Pierre, in turn, watched Marie record data in her small ledger, noting the meticulous loop of her M and the determined press of her pencil at the end of each line. Respect formed first, then camaraderie, then something softer that unfurled between them like the spiral of a galaxy. Conversations by the Seine. After evening lectures, they sometimes walked along the Quai Saint-Bernard where the Seine, dark as obsidian, carried lantern reflections toward the distant glow of the Eiffel Tower. Autumn leaves skittered across cobblestones, and their breath mingled in frosty plumes. They spoke of magnetism and molecular symmetry, of Polish folk songs and the novels of Zola. Pierre confessed he loved cycling across the countryside to observe cloud shadows moving over wheat. Marie admitted she still dreamed in Polish and sometimes woke whispering scientific terms no one had yet invented. One night, Pierre paused beside a parapet under a gas lamp halo, glanced at her with quiet earnestness, and said, "Vous êtes faite pour la science. You are made for science. If you were to need a laboratory, mine is open to you always." Marie felt warmth bloom in her chest, both from the offer and from the gentle conviction in his voice. Partnership forged. In July 1895, beneath vaulted ceilings of the Sceaux town hall, Marie and Pierre were married in a simple civil ceremony. She wore a dark blue serge dress chosen for practicality. "Something I may wear later in the laboratory," she explained. Their honeymoon was a cycling tour through the Isle de France, sleeping beside haystacks, tracing riverside paths fragrant with wild thyme, pausing to identify rock strata and iron-rich springs. Upon returning, they transformed a disused shed behind the École into a shared laboratory. The roof leaked, floorboards gaped, and winter winds prowled through broken panes. Yet to Marie the space felt like a cathedral of possibility. They installed Pierre's electrometer on a pine trestle. Marie tacked pages of spectral lines above a rough-hewn workbench. Together they dreamed of investigating a new enigma stirring within the scientific world: mysterious rays emitted by uranium salts, recently noted by Henri Becquerel. Pitch blend and patient toil. Marie proposed measuring the intensity of these rays across many minerals, seeking a pattern no one else had yet perceived. For months, she and Pierre labored side by side, crushing tons of black pitchblende ore in a cast-iron mortar, boiling the powder in cauldrons of acid whose fumes bit at their throats. The shed filled with clouds of dust that settled as gray velvet on sills and hair alike. Yet under the flicker of paraffin lamps, their eyes shone with the same quiet light of ambition. Late at night, when their arms ached from stirring vats and their fingertips tasted of iron, they would pause to examine residues under dim light. Certain fractions possessed an activity far beyond what uranium alone could explain. On evenings when exhaustion weighed heavy, Pierre would warm coffee on a spirit lamp, while Marie traced decay curves on squared paper, her pen moving in steady arcs even as candle wax puddled on the desktop. A soft glow in the darkness. Then came an extraordinary discovery. In a porcelain dish containing mere milligrams of a purified fraction, Marie observed a faint, bluish illumination, pulsing gently like a firefly trapped within stone. She beckoned Pierre, and together they bent over the dish, faces haloed by moonlight streaming through the cracked roof. "C'est magnifique," Pierre whispered. The luminescence felt almost living, a silent affirmation that they had stepped into a realm of hidden energies. They named the first new element polonium, in honor of Marie's homeland, and soon after isolated a second, far more radiant substance they christened radium. Yet in that initial moment, two figures leaning over a soft blue glow in an unheated shed. The grandeur of Nobel Prizes and global fame lay still beyond the horizon. What filled their hearts was something quieter, an intimate wonder shared, a promise that together they could coax new truths from the universe. Toward the next chapter. As clocks tolled midnight across Paris, Marie quenched the flame beneath a bubbling beaker, and Pierre secured the laboratory door with cold, stiffened hands. Outside, the city's avenues glittered with frost, but their minds glowed warmly with ideas that refused to sleep. Arm in arm, they walked toward the square on Rue Malfatard, lantern light shimmering on wet cobbles, discussing half-lives and crystal lattices the way other couples might speak of theater or wine. High above, Orion tilted its bright shoulder over the rooftops, silent witness to a partnership destined to reshape science. Somewhere in the darkness, pitchblende waited in burlap sacks, concealing futures of luminous paint, healing rays, and perilous lessons. But for now, the night belonged to possibility. Marie's boots tapped a gentle rhythm beside Pierre's measured strides, and their shared shadow stretched long behind them, two outlines merging into one path of discovery, leading onward toward radiance that would light not only laboratories but the world. Isolating polonium and radium. Winter soon melted into a damp Parisian spring, and every morning the tin roof of the Curie shed rang softly beneath the slow drum of falling rain. Inside, the air smelled of wet burlap and nitric acid. Rows of pitchblende sacks, black, mineral-rich earth hauled at great expense from the abandoned mines of Joachimsthal, leaned like weary travelers against the walls. Each sack contained 1,000 secrets. Marie Curie was determined to coax them into the light. Mountains of or milligrams of hope. The challenge before Marie and Pierre was almost absurd in its scale. In Becquerel's photographic plates, uranium salts had already revealed invisible rays, yet the activity Marie measured in crude pitchblende was several times stronger than pure uranium. Something else, something far more potent, nested inside the black ore, hiding in trace quantities measured not by grams, but by whispers of weight. To find that hidden heart, the Curies resolved to separate pitchblende into its chemical constituents, fraction by painstaking fraction. They received 2 tons of ore refuse that larger industrial labs deemed worthless. Delivery men dumped the jagged lumps in the courtyard. In drizzle and mud, Marie shoveled the pieces into iron cauldrons, then lit crackling charcoal fires beneath them. Steam and pungent fumes curled into the gray sky, while curious sparrows perched on guttering above, heads cocked as though witnessing alchemy. The orchestra of separation. Days became a symphony of repetitive motions. Crush. Heavy steel pestles thundered against stone mortars, reducing pitchblende to charcoal-colored dust that stained fingertips the hue of midnight. Bleach. Buckets of boiling hydrochloric and sulfuric acids hissed as powdered or was stirred in, releasing clouds of choking vapors. Filter. Slurry passed through linen sheets stretched over wooden frames, leaving gritty residue glistening like volcanic sand. Marie moved between stations with quiet focus, her skirt hem powdered gray, her boots always damp. She timed each boil with the precision of a metronome, noting when violet fumes rose or when a particular fraction changed color from ink black to umber. Even exhaustion seemed orderly. Arms aching in identical pulses, eyes stinging at regular intervals. Yet within that grueling cadence, wonder bloomed, tiny bright insights fluttering like fireflies amid smoke. Pierre, too, surrendered to the ritual. He calibrated quartz electrometers in a corner shielded by lead plates, measuring currents so faint they would have eluded most instruments of the era. Each sample's activity he logged on onion skin sheets, numbers rising and falling like breaths. When a fraction's ionization current spiked beyond expectation, he flagged it with a red wax, and Marie would replicate the purification sequence, narrowing the fractions further. Polonium appears. By early July 1898, a particular fraction of bismuth compounds sang louder than the rest. It crackled on photographic plates and drove Pierre's electrometer needle to life even across thin sheets of aluminum. Marie compared its spectral lines. Among familiar signatures shone a faint, unrecorded wavelength. In their cramped office she wrote a short communiqué to the Académie des Sciences. "We believe the existence of a new element, which we propose to call polonium, in honor of my native land." The paper was read aloud on July 18th, met with polite interest and quiet skepticism. After all, polonium's presence was inferred, not isolated. Its proof weighed less than a raindrop on the Seine. A furnace of perseverance. Undeterred, the Curies turned their gaze to a second, even more active fraction obtained from barium chloride residues. Its intensity was breathtaking, yet every chemical test insisted the powder was still nearly pure barium. In this contradiction, Marie sensed another hidden element. She resolved to purify the residue until the new substance declared itself unmistakably. They acquired larger cauldrons and moved operations into an abandoned hangar of the school's courtyard, where icy drafts scurried through cracked panes. There, Marie stood hour after hour over hissing baths of caustic soda, her hands shielded by thin leather gloves already pitted from acid. Each evening she and Pierre would unload cooling crystallization dishes, scraping pale green needles of barium radium chloride into labeled jars. The process repeated hundreds of times. Dissolve, heat, precipitate, filter, until mere spoonfuls of concentrate remained. In daylight the crystals looked unremarkable, but when darkness fell and oil lamps were extinguished, the substance came alive. A soft, pulsating bluish glow breathed from every jar, casting ghostly illumination across their tired faces. Even the workbenches shimmered faintly where stray grains had spilled, a gentle constellation of earthly stars. Naming the Sunstone. On December 26, 1898, they announced their second discovery. "We believe the existence of a second new element, strongly radioactive, which we propose to name radium, from the Latin radius, meaning ray." Parisian newspapers printed cautious articles, readers marveling that a husband and wife team in a dilapidated shed had perhaps uncovered nature's hidden fire. Skeptics voiced doubts. Where were the separated metal, the atomic weight, the spectra seen with clarity? Marie answered not with rhetoric but with relentless chromatography and ever sharper spectral lines. Months rolled into years. By 1902 she produced a decigram of nearly pure radium chloride, mass enough to weigh, to color flames bright carmine, to silence critics. The cost written in bone and breath. Yet the glow extracted a silent tax. Marie and Pierre handled radioactive salts with bare fingers, marveling as their skin tingled with warmth. Some nights they kept vials beside their bedside table, enchanted by the eerie light that banished all shadows. They knew little of the invisible particles dancing through flesh and marrow, altering hemoglobin, whispering changes at the cellular level. Paperwork from those months is flecked with burns. Small round holes where droplets of radium solution fell, paper fibers charred silently by alpha emissions. Marie's fingertips developed persistent sores. Pierre's joints ached in sudden bouts. They joked that science branded its servants. But bruises faded and experiments continued. Forward momentum felt inevitable, irresistible as time itself. Ripples of recognition. By spring 1903, word of the Curie's achievements had spread far beyond France. In Berlin, Ramsay attempted radium extraction. In London, Rutherford corresponded, eager to compare decay rates. Crowds filled lecture halls to glimpse samples glowing under dim lights, murmuring as though in a cathedral. That June, the Royal Institution invited Pierre to present the couple's findings. Marie, still barred by custom from speaking in that auditorium, sat among the audience, taking notes while radium's faint halo shimmered from a glass tube on stage. Applause thundered beneath the gilded ceiling. In that moment she felt both pride and a quiet ache for wider acceptance. Behind ceremonies, research pressed on. The Curies measured radium's enormous heat release, enough to keep ice melted indefinitely without external power. They coined the term radioactivity to describe the spontaneous emission of energy from atoms, proposing that elements could transmute, shedding identity like leaves turning to soil. A night of quiet triumph. In early December of that pivotal year, snow blanketed the boulevards of Paris in luminescent silence. Returning late from the lab, Marie and Pierre paused on Pont des Arts, breath crystallizing in moonlight. Their shoes crunched softly, the city hushed beneath a powder of stars. Pierre reached into his coat and produced a slim envelope, postmarked Stockholm. Hands trembling from cold and anticipation, he tilted it toward the bridge's lantern glow and read, "The Nobel Prize in Physics is hereby awarded jointly to Monsieur Antoine-Henri Becquerel, Monsieur Pierre Curie, and Madame Marie Curie for their discoveries in radiation phenomena." For a heartbeat, the world seemed to hold its breath. Then Marie smiled, a small, introspective curve of lips, thinking not of awards or applause but of the endless hours spent stirring cauldrons, of glowing powders illuminating the shed, of her mother's lullabies mingling with the hiss of acid. Soft echoes toward dawn. They walked on, envelope tucked securely between gloved fingers, the Seine reflecting lantern arches like elongated comets. Far upriver, Notre Dame's bells tolled a late hour. Pigeons nestled beneath flying buttresses, undisturbed. Marie imagined future nights in that drafty shed, vials still pulsing softly while new students approached with fresh questions. Radioactivity's path stretched far ahead, toward medical miracles, industrial marvels, and cautionary tales yet unwritten. But tonight, only gentle satisfaction filled her chest. She and Pierre had pried open a tiny window onto the universe's inner furnace. Through it poured light enough to guide many minds. As they left the bridge, radium's phantom glow seemed to linger in their wake, a moving constellation that merged eventually with morning's first muted hues of violet. And thus the chapter of discovery closed, not with fanfare, but with two weary scientists strolling through falling snow, pockets warm from Nobel telegrams, hearts warmer still from shared wonder. Nobel Prize and the lantern of fame. Snow still dusted the boulevards when, on a pale December morning of 1903, Marie Curie stepped into the gilded auditorium of Stockholm's Old Royal Academy. Crystal chandeliers shimmered high above, each droplet scattering sunlight into tiny prismatic constellations. The air smelled faintly of wax polish and cedar smoke from fur-collared coats draped across carved chairs. Marie's dark travel dress, chosen again for practicality, seemed almost fictional amid the sea of black tailcoats and white waist ties. Yet when she pressed a gloved hand to her chest, she felt the sure, steady drum of her heartbeat, a quiet metronome reminding her that discovery owed no allegiance to spectacle. As King Oscar II rose, a hush rippled through the hall. His voice, sonorous and formal, recited the citation in measured Swedish syllables. "For your extraordinary services in advancing our knowledge of radiation phenomena." Polite applause washed the marble floor like a restrained tide. In that instant, beyond the pomp, Marie's mind drifted to Rue Cuvier. The peeling walls, the scent of damp charcoal, the blue glow of radium illuminating chipped beakers. She realized the Nobel medal did not commemorate a single moment of triumph. It was an echo of innumerable, nearly invisible moments. Each time she tightened a clamp with numb fingers, each line of data inscribed by candlelight. The return to Paris. When the Curie's train pulled into Gare de l'Est on Christmas Eve, night had already folded itself around the city. Word of their award preceded them. Clusters of well-wishers stood on the platform, holding newspapers and small tricolor flags. Reporters pressed forward, notebooks poised, questions tumbling. "Madame Curie, how does it feel to be the first woman to win the Nobel Prize?" Flash powder erupted in dazzling white clouds, leaving Marie momentarily blind. Pierre shielded her with a gentle arm, guiding her past the swarm toward a waiting fiacre. Their apartment on Boulevard Kellerman overflowed with telegrams, bouquets, and parcels wrapped in violet ribbon. Yet among the congratulatory notes lay more urgent letters. Universities requesting lectures, investors proposing radium factories, patent offices offering lucrative contracts. Pierre stared at these invitations as though they were curiously shaped insects. "It is not radium's glow that must light the world," he murmured, "but the knowledge of its nature." Principled gift. True to that philosophy, the Curies made a radical decision. They would not patent the radium isolation process, nor charge fees for access to their data. "The element belongs to all humanity," Marie wrote in a letter to a German physician seeking samples for cancer therapy. In relinquishing potential fortunes, they affirmed a deeper wealth, one measured in open collaboration rather than private gain. The scientific community responded in kind. Laboratories from Boston to Budapest began refining radium, sharing yield tables and spectral lines. Within a year, fragile vials traveled across oceans nestled in lead-lined teak boxes, destined for hospitals where surgeons experimented with shrinking tumors by pinning minute quantities of radium salts to gauze dressings. Patients described a peculiar warmth, as though sunlight penetrated flesh. Some tumors receded. Others remained stubborn. Yet hope, bright, untested, entered the wards alongside that ghostly luminescence. Fame's weight. For Marie, acclaim arrived not as triumphant music, but as an ever-thickening fog. Invitations outpaced stamina. Committees expected speeches polished like mirrors. Newspapers dissected her wardrobe, her accent, even her handwriting. She received letters praising her as the embodiment of modern womanhood, while others scolded her for abandoning domestic duty. On certain mornings, fatigue gathered behind her eyelids like fine dust, and she longed for the anonymity of Warsaw's flying university, where ideas, not identities, mattered. Still, she accepted lectures at the Sorbonne, becoming its first female professor. Students crowded the amphitheater, jostling for vantage points. She entered briskly, chalk holder in hand, and without preamble sketched a decay curve that fell, smooth, relentless, toward the horizontal axis. "Observe," she said softly, "matter changing its very essence." Her voice carried calm authority, devoid of rhetorical flourish. In that sparse style, young minds sensed the vastness of what she implied, that atoms were not immutable building blocks but restless creatures, shedding energy, transmuting identities. The laboratory of the future. Recognition brought leverage. Leveraging her Nobel prestige, Marie petitioned the French government and the Pasteur Institute for funds to create a dedicated institute du radium. Bureaucrats, still dazzled by radium's therapeutic promise, agreed. Ground broke in 1906 on a parcel of land off Rue d'Ulm. Marie oversaw blueprints, insisting on wide windows for natural light, lead-lined walls, and ventilation ducts that would carry radioactive dust away from lungs yet unaware of its danger. Before the roof beams were set, tragedy struck. On a rainy April afternoon, Pierre, hurrying across the Rue Dauphine, slipped on wet cobblestones and fell beneath the wheel of a horse-drawn cart. His skull fractured. By the time passers-by lifted him, life had fled. The telegram reached Marie as she annotated student theses. Ink pooled on the page, the pen slipping from her grasp. Grief and resolve. The days that followed blurred. Condolences delivered through half-open doors, the smell of lilies wilting in dark rooms, the hush of two small daughters, Irene and Eve, observing their mother's unshed tears. Yet grief, like radium's invisible rays, manifested both damage and strange energy. 3 weeks after the funeral, Marie returned to the half-built institute, her black veil trailing among bricks and scaffolding. Work resumed under her direction. Copper pipes clanged, hod carriers sang off-key. Sorrow fused with purpose, hardening into an alloy no despair could crack. The second quest for purity. Even as construction continued, Marie embarked on an audacious measurement, establishing radium's atomic weight with higher precision than ever attempted. Alone at midnight, she dissolved salt after salt, driving out moisture in porcelain dishes that glowed sky blue. Her hands, knitted by callus and occasional bandage, manipulated microbalances delicate enough that a moth's wing might skew readings. After months of repetition, the number emerged: 225.93. Its certainty thrilled her more than applause ever could. She submitted the findings to the Académie des Sciences, quietly confident yet keenly aware some colleagues still doubted a woman's capacity for such rigor. The data stood unassailable. Skepticism evaporated like morning frost. Laurels multiplied. In 1911, whispers from Stockholm reached Paris. The Nobel Committee, swayed by her new measurements and further isolation of pure radium metal, had voted to award her the prize in chemistry. She became the first person, man or woman, to hold 2 Nobel medals. Yet the same newspapers that once extolled her genius now splashed lurid headlines about her friendship with physicist Paul Langevin, implying impropriety. Crowds jeered outside her apartment. Stones shattered window panes. Inside, Marie cradled her daughters and wondered whether public adoration always carried a serpent's bite. Einstein, learning of her plight, wrote a letter. "Do not read that hogwash but continue your work. The noisy rabble lusts for sensation." She folded the note into her pocket and set quill to paper once more, drafting the Radium Institute's charter. If notoriety was inseparable from achievement, she would outwork it, outrun it, transform it, the way radium's alpha particles transmute atoms into something entirely new. Light beyond laboratories. The institute opened in 1914. A month before thunderheads of war roiled across Europe. Yet even as trenches carved scars into Flanders soil, the building's windows burned faintly with activity at all hours. Researchers, many of them women Marie personally recruited, studied radiation therapy, ionization chambers, and radioimmunology. At dusk, the courtyard filled with soft conversation in Polish, French, English, a babel united by isotopes. Visitors often found Marie alone in the basement, cataloging samples by lantern light. Radium chloride crystals glinted in small glass ampoules like captured nebulae. She handled each carefully, labeling them with precise mass, date, and spectral notation. High overhead, the city's electric lights flickered, but down here a subtler radiance prevailed, one that owed nothing to wires or coal. Closing vignette. One winter night, as sleet tapped the laboratory skylights, Marie adjusted the collar of her worn lab coat, now patched at the elbows. She placed a thread of radium salt on a photographic plate and waited in silence. No flash, no spark, only the steady emission of unseen quanta. After an hour she developed the plate, white pinpricks, clusters, galaxies where particles had struck. She smiled quietly, reminded that fame, like those tiny dots, was but a surface pattern. The truer legacy lay in the invisible forces she had helped reveal, energies humming through granite and bone, through starlight and the human spirit alike. With a final note in her logbook, she extinguished the lamp. The room did not fall dark. Ampoules on the shelf continued to glow, tracing pale outlines of beakers and retorts. Marie Curie paused in the doorway, watching that gentle light curve around every shadow, a silent testament that learning, once kindled, can outshine the longest night. X-rays for the front, les petites curies. Barely a month after the Radium Institute's doors first opened, the roar of artillery echoed across Europe. In August 1914, France mobilized. Troop trains thundered east, their windows stuffed with tricolor flags and bouquets hastily thrust into soldiers' hands by weeping families. Marie Curie watched the columns march along Boulevard Saint-Germain and felt a familiar tightening in her chest, the same ache she had known as a schoolgirl under Russian occupation. Again science and hope were threatened by the machinery of war. A hidden weapon, invisible light. Wounded men soon flooded Parisian hospitals. Surgeons, slicing uniforms sticky with mud and blood, groped blindly for bullets lodged near arteries or splintered bone. X-rays, discovered less than 20 years before, could reveal those lethal shards, yet few French hospitals owned a radiographic apparatus, and fewer still possessed staff trained to use one. Marie saw in that deficiency not an obstacle but a summons. If armies carry cannon to the front, she told a skeptical military official, then science must carry light. Building the first mobile units. She requisitioned a battered delivery van, stripped its cargo box, and installed a compact induction coil, a Crookes tube, and a photographic plate cabinet padded with horsehair to survive jolts of cobblestone roads. A small gasoline generator and heavy lead shielding completed the ensemble. Atop the rear doors she painted a discreet red cross. Mechanics at Renault, bemused by the lady professor, showed her how to gap spark plugs and patch a split fuel line with wax twine. Within 3 weeks the prototype rolled out of the institute courtyard smelling of fresh paint and hot oil. Marie climbed to the driver's perch in goggles and a linen dust coat, white hair tucked beneath a borrowed army cap. Irene, then 17, hopped beside her, clutching a crate of glass plates cushioned by straw. They rattled toward the Marne where field hospitals sprawled under canvas the color of dried blood. Orderlies stared as the van coughed to a stop, its coil thumping like a mechanical heartbeat. "En voiture radiologique," Marie announced. "We expose the wound to light. Baptism by fire." Inside a barn thick with ether fumes and kerosene lantern smoke, Marie balanced a fragile glass tube between sandbags while Irene slid a plate behind a groaning sergeant's shattered thigh. The high-tension coil snapped blue sparks. The tube flickered green. Ozone stung their throats. Minutes later, in a makeshift darkroom, the negative emerged. Ghostly bones, a bright oval bullet nestled millimeters from the femoral artery. The surgeon whistled low and adjusted his scalpel by that spectral map. The man lived. Word spread along the trenches faster than dispatch riders. Soon commanders wired Paris pleading, "Envoyez la femme Curie avec ses lumières invisibles," multiplying the light. Marie drafted engineers, electricians, even theatrical stagehands idle after the Paris opera went dark. Together they outfitted 21 additional vans, each christened Petite Curie by grateful soldiers. She cajoled manufacturers for copper wire, scavenged lead from demolished roofs, bartered institute radium salts at cost to hospitals in exchange for vacuum tubes. Training operators proved harder. Many radiologists were at the front or dead. Marie therefore opened the institute basement to women volunteers, teachers, seamstresses, society widows. Over 6-day crash courses she taught them anatomy, basic electricity, plate development, and elementary radiation safety, though the dangers were still poorly understood. By winter she had dispatched 150 women and girls, Irene among the first, each armed with a handbook scrawled in Marie's tidy script and a whistle to summon orderlies. Life along the lines. Mud, lice, and shellfire became their lecture hall. The vans lurched through ruined villages where church steeples lay across cobbles like toppled obelisks. Generators sputtered in freezing rain. Glass plates cracked from bitter cold. Her pupils learned to warm chemicals against their own ribs to keep developer fluid from icing. Some nights they slept in haylofts sweet with fermenting straw, other nights in dugouts that smelled of chlorinated lime and fear. Yet when the induction coil hummed, the barn or bunker seemed to expand, filled with the solemn hush of revelation as bones glowed onto glass. Marie herself logged more than 10,000 kilometers behind the wheel, steering past columns of POWs and ambulances stacked 3 men high. At each stop she recalibrated machines, replaced flickering tubes, scrawled doses into a leather ledger already smudged with fixer stains. Officers offered citations. She declined, requesting petrol vouchers instead. "Petrol turns into pictures," she explained, "and pictures turn into saved limbs. A portable sun in a glass vial." Late in 1915 she recognized another need. Precise localization of deeply buried fragments invisible even to X-rays. She recalled radon gas, an ephemeral descendant of radium that could be sealed in thin glass needles. Introduced into a wound track, the needles emitted gamma rays detectable by ionization chambers, guiding surgeons like a lantern inside flesh. With a small grant from the Red Cross, Marie converted a laboratory closet into a radon extraction room, its walls dripping with condensation from iced brine coils. Wearing leather gauntlets, she teased the invisible gas into hair-thin capillaries, clipped them shut with jeweler's forceps, and packed them in velvet-lined tins. Front surgeons quickly dubbed them Curie seeds. By war's end, more than 1 million seeds had been implanted, pioneering what would later be called brachytherapy. Marie made no claims of invention. She merely noted in her diary, "Radon travels where we cannot and shows what we cannot see. Toll upon the body." All the while, radiation whispered its silent calculus through her marrow. Fingertips cracked. Fatigue settled in her bones like winter damp. She ignored both. Only when Erin collapsed with a fever and bleeding gums did Marie halt, ordering her daughter home to convalesce on boiled milk and sunshine. Doctors murmured anemia d'origine obscure. Marie swallowed guilt with black coffee and returned to the front alone, sleeves rolled to the elbow, forearms stippled with faint burns that glowed faintly under ultraviolet lamps. Armistice and appraisal. November 1918 arrived on the echo of church bells and the distant thrum of retreating artillery. Vans rolled back through the Arc de Triomphe, their gray paint scarred by shrapnel, their coils coated with grime. Records tallied more than 1 million radiographs performed and tens of thousands of limbs spared amputation. The French government offered Marie the Légion d'honneur. She declined yet again, requesting funds instead to refurbish the Radium Institute's war-weary equipment. "Honors wear out faster than induction coils," she quipped. Quiet reckoning. In the first peacetime winter, Marie walked the deserted institute corridors long after students had gone, the floor ticking under her sensible shoes. She paused before a cabinet where cracked glass plates from the front were stacked like thin tombstones, images of pelvises pierced by jagged steel, spines peppered with shrapnel dust, children's femurs snapped like reeds. She shut the door gently. The war had proven that invisible forces could both maim and heal. The task ahead was to bend them ever toward tenderness. She drafted a new curriculum. Medical radiology, dosimetry, radioprotection, words scarcely voiced before. Erin, recovered and newly graduated, accepted a junior post. Together they uncrated the surviving Petites Curies, salvaging coils and lead glass for student demonstrations. At night, mother and daughter compared exposure logs, plotting dose against healing as astronomers plot magnitude against distance, seeking patterns that might spare future patients and practitioners alike. Lanterns relit. In 1921, at the invitation of American journalist Marie Maloney, Marie Curie embarked on a fundraising tour of the United States to purchase a gram of radium for her institute. Commercial price: $100,000, a king's ransom. She crossed the Atlantic aboard the Olympic, pale and fatigued but determined. College girls showered her with roses in New York. President Harding placed the radium in her gloved palm within the White House, remarking, "You have harnessed the fire of the sun." She smiled wanly, thinking of muddy barns, cracked plates, and the whine of the induction coil, the real crucible where that fire had been tamed for mercy. Epilogue of the war years. Thus ended Marie Curie's campaign of light. She had driven more kilometers than some generals, trained an army of radiologic nurses, and transformed radon seeds into silent scouts within living tissue. Yet she kept no souvenirs except a dog-eared road map of the Western Front, its creases darkened by iodine spills. On its margin she had penciled a single line: "Science serves humanity when courage steers the wheel." With the vans dismantled and peace uneasy but real, Marie turned once more to pure research. Yet the war's lesson glowed within her like a low blue ember. Knowledge, when shared and nimble, could move faster than destruction. And in the long hush that followed the guns, she resolved that the Radium Institute would remain forever a workshop of such nimble light, ready to roll wherever darkness gathered. Gentle science notes for relaxation. Settle in comfortably, breathe slowly, and let your thoughts glide like moonlight over still water. In this quiet chapter we drift away from crowded laboratories and thundering battlefields, pausing instead to admire the delicate, almost whisper-soft curiosities that sprang from Marie Curie's work. Tonight these facts are not summoned to astonish, but to soothe, each one a feather-light vignette inviting your mind to float, unhurried, toward restful sleep. 1 of the lantern's stone. Imagine holding, in gloved hands, a crystal no bigger than a sugar cube. You extinguish the surrounding lamps and watch as the crystal exhales its own dreamy glow, blue-white, like frost catching starlight. That is radium chloride in darkness. Its soft radiance is not a reflection but an inward hum of energy, tiny particles slipping free from atomic orbits, each departure leaving behind a sigh of light. Marie often stored such crystals in wooden drawers. Students opening them at night found the entire cabinet shimmering as if constellations had been folded into cedar. To a heat that never sleeps. Radium does more than shine. Even in perfect blackness it releases a faint, constant warmth, about 100 calories every hour for each gram, enough to keep a thimbleful of water from freezing on a winter windowsill. Marie Curie once suggested placing a radium ampoule inside a tiny steam engine to spin a toy wheel forever, powered by the quiet breath of atoms. He never built it, yet the image endures, a perpetual whisper of motion, like a child's pinwheel turning in the gentlest tide. 3. Polonium's quiet strength. Polonium, named for Marie's homeland, does not glow to the eye, yet its invisible energy is among the most intense known. A single milligram of polonium, 210, can warm itself to 500 degrees Celsius, though it sits cool in the palm when safely sealed. During early space exploration, engineers tucked pinhead amounts inside tiny heaters to keep lunar instruments from icing over the Sea of Tranquility. Thus, an element discovered in a drafty Paris shed eventually cradled fragile circuits on the silent moon. For a radon's midnight footprints. Breathe out slowly, and picture the exhaled mist on a frosty morning. Inside every plume a few atoms of radon drift upward, descendants of uranium deep inside Earth's crust, traveling through rock fissures for centuries before slipping into open air. They linger briefly, then transform once more. In mountain spas of the early 1900s, patients soaked in warm radon pools lit by stained glass skylights, believing the gas would renew tired blood. The air tingled faintly with ozone. Violins played. Steam rose and twirled beneath painted rafters. Whether cure or illusion, many left whispering that the very air felt enchanted. 5. The phantom clock hands. Close your eyes and picture a pocket watch held beneath a blanket after lights out. Tiny numerals and hands glow pale green, letting travelers read time without striking a match. Between 1910 and 1930, that glow came from paint made of radium salts mixed with zinc sulfide. The mixture was nicknamed undark, an ironic name for a darkness-eating pigment. Later, safer phosphors replaced it, yet collectors still find century-old watches quietly gleaming in desk drawers, a fragment of Curie-era science ticking on through generations. 6. Paper charms that sing. Marie discovered that thin leaves of foil, if hung beside a radium source, quivered as though stroked by an unseen breeze. Invisible particles bombarded the foil, charging it with electricity until like charges repelled and the leaf twitched. Early teachers borrowed the trick, suspending gold foil in jam jars to let children see the intangible. In dim classrooms the foil leaves danced, delicate as moth wings, whenever the vial drew near, proof that the universe thrums with forces beyond ordinary sight. 7. A snowfall of light. Place a high-sensitivity photographic plate next to a sealed radium ampoule overnight. In the darkroom you will find the developed plate sprinkled with white specks, like a snowfield under dawn's first ray. Each point marks a single particle striking silver bromide crystals, exposing them momentarily. Hold the plate sideways and the specks seem to hover in black space. A silent meteor shower captured on glass, every pinpoint an echo of atoms changing form. 8. A half-life. A gentle clock beneath matter. Picture a candle that never gutters, yet grows imperceptibly shorter by the second. Half-life is the quiet tempo at which a radioactive element dims. Radium-226 takes 1/600 years to lose half its brightness. Polonium-210 only 138 days. In this way, every isotope owns a private metronome, ticking patiently inside mountain or sea silt or antique compass dials. When you next notice a clock hand glide forward, remember that beneath stone quarries, beneath your very pillow, quieter clocks advance too, marking the ancient breath of the world. 9. Alpha, beta, gamma. A lullaby in 3 notes. If radioactivity were music, alpha particles would be slow drum beats, heavy helium nuclei strolling only centimeters through air before resting. Beta particles would be quick violin strokes, electrons darting meters in a bright staccato. Gamma rays would be pure, lingering flute tones, massless photons flying years through the cosmos. Marie helped show that atoms play all 3 notes at once, composing a silent lullaby that rustles beneath everyday experience. Tonight, let each note settle over you. A low drum, a swift string, a breathy flute, slow, quick, far away, guiding you towards stillness. 10. A rose that lingers in darkness. Late in life, visitors sometimes found Marie pressing a freshly cut rose to a radium vial for an hour, then setting the blossom on her nightstand. After lamps were blown out, the petals glimmered like frost-tipped embers, the phosphorescent salts sharing borrowed light. By morning, the glow faded. The rose remained gently perfumed, an ordinary bloom again. Science, Marie once wrote, is the art of borrowing strangeness from nature, then returning it with thanks. The rose, briefly luminous, was her fragrant signature on that sentiment. 11. A whispers in cloud chambers. A mist-filled chamber cooled by dry ice lets vapor condense on charged particles. Bring a speck of radon near, and thin, silvery trails scroll across the mist, curling, branching, fading. Watching these trails is like following breath of invisible fireflies through fog. Many students first glimpse the tracks of the atom in such chambers, feeling awe slip quietly under their skin. Perhaps that hush of awe is the universe's most delicate element, one yet to be plotted on any periodic table. 12. Auroras under your skin. Iron atoms in blood align faintly with magnetic fields. Calcium in bones scatters cosmic rays. Potassium-40 inside every muscle fiber decays now and then, sending minute energy outward. You are, in a modest way, a shimmering aurora of subatomic events, soft lights that mirror the northern sky. Knowing this can bring comfort. While you rest tonight, gentle sparks of transformation continue their slow ballet, keeping time with the planet itself. 13. A legacy in 2 decigrams. At the Radium Institute archive sits a small lead-lined case containing Marie Curie's personal supply of purified radium chloride. 2 fragile glass capsules, together weighing just 2 decigrams. They still glow faintly through ultraviolet glass, though human eyes can no longer perceive it unaided. Instruments confirm the flicker will persist for thousands of years, long after the case decays, long after the surrounding stone weathers. It is a candle set in deep time, inscribed with her quiet conviction that knowledge, once kindled, outlives its keeper. In these gentle facts we glimpse how a single mind, working by candle and perseverance, coaxed hidden light from humble stone. Let that realization settle around you like a warm quilt. Our world is woven with quiet wonders, each waiting patiently for someone to lean close and listen. As you drift toward sleep, imagine those unseen lanterns, tiny, tireless, glowing beneath mountains, within rose petals, inside your own steady heart. May their calm, persistent shimmer guide you into deep and restorative rest. Twilight years, quiet legacy, and a gentle drift toward sleep. Night is deepest just before dawn, And in the long twilight of her life, Marie Curie's work settled into a hush as comfortable as a thick wool blanket. She no longer chased trains or stirred boiling vats. Instead, she moved slowly through quiet corridors lined with apparatus she had once built with her own blistered hands. Let us walk beside her, soft step after soft step, and feel the calm after decades of tireless light. 1. The garden on Rue d'Ulm. Picture an inner courtyard paved with pale flagstones, a few sycamores rustling overhead. Each morning Marie paused here, fingertips brushing the bark, listening to leaves applaud the passing breeze. She had asked the architects for this garden so researchers might breathe fresh air between experiments, proof that discoveries, like trees, needed sunlight and silence. Today the benches sit empty, dew beading on slats. You can almost hear the heartbeat of Paris beyond the walls, steady, unhurried. 2. Irene and Frederick. Marie's elder daughter Irene, quick-eyed and resolute, married physicist Frederick Joliot. Together they coaxed artificial radioactivity from light elements, splintering atomic nuclei with carefully aimed neutrons. An echo of polonium breaking from pitchblende, but now in deliberate choreography. When their 1935 Nobel telegram arrived, Marie murmured, "The torch passes." She did not seek credit. She simply smiled and returned to her manuscripts, content that new hands carried the flame. 3. Eve and the piano in the attic. Her younger daughter, Eve, chose music and words over mathematics. Late afternoons she played Chopin in the institute attic, the notes floating like fireflies through heating vents. Marie would pause mid-calculation, close her tired eyes, and let the nocturnes wash away the throb of swollen joints. Science, she believed, thrived on such intervals of unreasoned beauty. A nocturne for the spirit, as radium was a nocturne for the dark, for a journeys under soft sun. Doctors advised Marie to rest her eyes, clouded by cataracts tinted faintly blue from decades of radioactivity. She traveled instead to San Selmas in the Alps, where pine needles scented the air and glacier melt whispered along stone gullies. She collected alpine flowers, gentians the color of midday sky, and pressed them between notebook pages, labeling each with Latin care. A different kind of spectrum, she joked, turning petals to data. 5. A library of glowing paper. Back in Paris, most of her notebooks, aprons, even recipe cards remained faintly radioactive. Archivists stored them in lead-lined boxes, texts that could not be safely opened without gloves and Geiger counters. Marie found this quietly amusing. Knowledge so luminous it required shielding, paragraphs that would outlive their author by millennia. She signed the accession forms with decisive strokes, then tucked the pen behind her ear as if filing the moment away. 6. Invisible ink on the world. Close your eyes now and imagine every hospital X-ray, every PET scan, every radiotherapy oncologists deploy each dawn. Let them drift before you like translucent petals on a slow river. Each carries a faint watermark, Curie's invisible signature, inked not in letters but in possibility. While you breathe gently, thousands of technicians adjust collimators, align patients, and trust that light from hidden atoms will reveal paths to healing. That quiet utility is the true monument. No marble, only mercy. 7. A last notebook, last formula. On a June evening in 1934, Marie set down her spectacles and wrote a final line in her radium blue ledger. Measurements stable. Repeat in fresh air tomorrow. Exhaustion swept over her like dusk. A week later she slipped into fever, her blood struggling beneath decades of unseen exposure. At a sanatorium in Passy, the windows were flung wide so mountain air could roam the room. She whispered one word, radium, gentle as a lullaby, then rested. The nurse noted the time. Outside, a solitary star peeked into dawn-streaked sky. 8. An echo of blue. Scientists sealed her personal radium in a quartz ampoule and set it beneath soft violet glass in the institute foyer. On certain evenings, when hallway lamps dim for cleaning, a caretaker might notice a bluish nimbus lingering there, barely perceptible like memory itself. He nods respectfully and turns the key, leaving the glow to keep silent vigil until morning researchers shuffle in with coffee and fresh questions. 9. The earth turns, yet the half-life flows. A half-life is always a beginning as well as an end. Atoms transforming, releasing energy, becoming something new. So too with human endeavor. Marie Curie's tangible years decayed gently into history, but the energy of her curiosity streams onward. Through classrooms, clinics, satellites mapping cosmic gamma flashes. When you feel the planet rotate under stars tonight, know that her work still hums softly in every illuminated hospital corridor, every infrared image of a far galaxy, every glowing exit sign guiding travelers through dark cabins. 10. A quiet guidance into sleep. Let these images settle. The tiny glowing ampoule, the sycamores rustling in an institute courtyard, piano chords drifting through vents, alpine gentians pressed between notebook leaves. Feel gratitude for the patient light that guided one woman's steady hands, turning stone to healing and night study to global dawn. With each exhale, imagine that light dimming to a comfortable ember, warm enough to watch over your dreams but gentle enough not to wake you. Breathe in, breathe out. The hidden atoms continue their silent dance. You need only rest. May this knowledge cradle you like a soft lantern placed just beyond the curtains, promising that discovery never sleeps, and that, for tonight, you can. Epilogue and sleep lullaby. Take one more unhurried breath. Feel your chest rise, then fall, like a small boat settling onto dusk-colored water. The story of Marie Curie has traveled a long arc tonight. From candlelit notebooks to glowing crystals, from battlefield vans to alpine meadows. Now we let that arc soften into a single steady point of light, faint, warm, and constant, guiding you toward restful sleep. One or a lantern in the mind. Picture a quiet hillside just beyond Paris. A single lamp stands on a wooden post, its glass chimney glimmering pale blue. That lamp is everything Marie discovered. Radium's whisper, polonium's spark, the hush of unseen rays. It doesn't blaze. It does not need to. Its task is only to persist, the way knowledge persists, steady through night wind, patient beneath drifting clouds. Imagine resting on cool grass watching that lamp. No hurry, just breathing and watching. 2. A gentle footprints of influence. As you lie there, faint echoes drift down the hill. The click of Geiger counters in far-off laboratories, the hushed gratitude of patients whose tumors have melted under modern beams, the scratch of students' pens as they plot decay curves. Each sound is soft, like distant footsteps on moss, reminding you that curiosity walked this path long before, and will continue long after your brief vigil. 3. 3 slow heartbeats. Let us slow still further. 1. Inhale 4 counts. Hold 2, exhale 6. Feel shoulders melt. 2. Notice the weight of blankets, how they settle exactly where they need to. 3. Allow eyelids to drift half closed, letting the lamp's glow blur into a single soothing color. For the half-life of worry. Worries, like radioactive atoms, decrease with time. Each breath you release cuts their intensity by a quiet fraction. There is nothing you must solve tonight. Calculations can wait in the margin until morning. Let every exhale be one half-life. Let them fade. 5. A minute of rain. Now, if you wish, imagine rain beginning. Gentle, even silver threads falling through lamplight. No thunder, only the soft percussion of droplets on leaves and earth. Reader. Pause 60 seconds, or overlay low-volume rain ambience. 6. A stars hidden in stone. While you breathe, distant mountains cradle or still rich with uranium, atoms created in stellar furnaces billions of years ago. These sleeping stones hold tomorrow's discoveries, but they are in no hurry. Neither are you. The universe itself is patient. It grants you permission to rest. 7. The library after midnight. Return now to the Radium Institute. All corridor lights are dim. Shelves of journals glow faintly where radium dust once settled. Caretaker keys echo then fade. Between ticking clocks you hear only your own calm heartbeat and the distant river of Paris outside. Any page you open shows equations you may read later. Tonight the margins themselves are enough. Blank, quiet, inviting sleep to write its own gentle formula. 8. A gratitude candle. Imagine striking a match. Small, sulfur-sweet. You light a bedside candle. Inside the flame dance colors Marie once analyzed through prisms. Sodium's amber, copper's green, potassium's pale violet. Offer silent thanks, for teachers, for questions, for quiet rooms, and for the simple gift of breath. Blow the candle out. Watch its smoke curl upward, carrying gratitude into the dark like a ribbon. 9. A drift sequence. 1. Feel toes relax, then ankles, calves, knees. 2. Let the sense of weight travel upward. Hips, lower back, each vertebra settling into mattress. 3. Shoulders melt. Arms grow pleasantly heavy, palms open. 4. Jaw unclenches, tongue rests, eyelids sink fully closed. 5. Thoughts become soft shapes. No edges, no urgency. 10. A final image. See again the hillside lamp. Rain has stopped, clouds part. Above it, uncountable stars shimmer, quiet as dew. The lamp's blue glow and the starlight mingle until you cannot tell where one ends and the other begins. That merging is sleep. Step into it. Let the night carry you the rest of the way. Good night, traveler in science and rest. May your dreams glow gently, steady, patient, ever curious, until morning paints the horizon with new questions, and you wake refreshed, ready to follow their light.